Hey, what's up, folks? How is it going? This is Avijit here, and welcome to Devops Challenge Hub. So let's start with today's interview question. And today's interview question is on subnet architecture, and we will have multiple questions today. We'll discuss about public versus private subnets. Then we'll discuss about what are route tables, internet gateway, NAT instance, NAT gateway, etc. Okay. So let's start with what are the key differences between public and private subnets. We already discussed about public and private subnets in previous interview questions. Uh, so let's, but today we'll discuss in a structured way. So public and private subnets. So public subnet will have internet access, bi-directional internet access, and private subnet means no direct internet access. At least in the private subnet, there won't be any uh, inbound connection. From outside, you won't be able to connect, but from inside, you may be able to connect. That may be there, but it won't be bi-directional. So it's a private. So nobody will be able to come inside. But public subnet, it's a bi-directional. Route table has a route to internet gateway. So it has a route to internet gateway. So like from from your building, there is a route to main gate, and from main gate you can go to the road. Similarly, it has a route to internet gateway, and from there it can exit. Route to NAT gateway or instance for VPC endpoint only. So route to NAT gateway or NAT instance, and it can go out like to download some packages, but external traffic cannot come inside. You cannot initiate connection to a private instance in a private subnet. Internet gateway directly connected to internet gateway. Private subnet will be directly connected to this. There won't be any connection to internet gateway for private subnet. Public IP assignment, resource can have public IP addresses. In public subnet, it can have public IP addresses, but in private subnet, it will only have private IP. It won't have public IP. Inbound traffic can receive inbound traffic from internet. From internet, you can receive, but cannot receive inbound traffic from internet. So that's why all the web servers will be here in public subnet, and database will put it in the private. Outbound traffic, direct outbound traffic is there. Outbound traffic via NAT gateway. Security, more exposed to internet threats. This is more secure. Private is more secure, isolated from direct internet access. Use cases, web servers, load balancer, Bastion host, all these will be on public subnet. Database server, application servers, internal services will be on private. Cost-wise, lower cost because no NAT gateway needed, and here higher cost little bit because of NAT gateway for internet access. Visibility, publicly accessible if security groups are up, and it's hidden from the internet, only accessible internet. The private subnet is hidden from the internet. And common resources, public facing web application, CDNs, and backend database, internal APIs, processing services, all these will be in the private subnet. So these are the key difference between public subnet and private subnet. Now let's go to what goes in each subnet type. What are the key components? So public subnet typically will have load balancer, application load balancer, network load balancer, web server, which need direct access to internet, Bastion host for SSH access, NAT gateways. So these are all will be in public subnet. What are there in private subnets? Application server, database server, internal macro services, internal some APIs, which will be used internally, backend processing systems, log, etc., like monitoring system, etc. So they are typically will go into private subnet. How do you place subnets across availability zones? Right? So in earlier interview question list, we discussed how we discussed that subnet cannot span across multiple availability zone. So one subnet, one availability zone. And so think about like a hospital, how will you place subnets across availability zones? So smart design will be emergency room in, you will put it, will keep emergency room one in building A, maybe in another one, maybe in another building B in another data center, I mean, it's another location. Operating rooms will be in two different buildings so that our patient's record should be accessible from both buildings so that if one building lose power, B building continues with all the operation. Similarly, high availability pattern, let's say you have there are 6 availability zones or 6 data centers. So at least 2 availability zones you'll be using, minimum 2. So that backup is there. One public subnet you will keep in one availability zone, and then another public subnet in another availability zone B. So public subnet, then private subnet in availability zone A, then public and private availability zone 1B. Okay, so that way. So these are the CID notation. CID notation we discussed earlier. So this allows you to deploy load balancer, web server, app server, database server across multiple agents for redundancy. So we'll go by this high availability pattern. So that's how we'll place subnets across availability zones. So how would you place subnets across availability zones? We need to have, it will be like multiples. In one zone, we will have public, private, another zone, public, private. If this zone is down because of the power supply, etc., or something happened, so another zone will be able to take care. So that's a backup. Why can't I just put everything in one zone? Obviously, we don't want a single point of failure. We need a backup. So if one availability zone issues, power outage, network problem, hardware failure, your entire application becomes unavailable. So multi-agent deployment ensures that if one agent fails, one availability zone fails, your application continues running from other availability zones. We want to avoid single point of failure. That's why we can't put everything in one availability zone. How do you plan subnet CIDs within a VPC? So let's say your office has a total available, like we can, this can be your VPC IP address range. So by 16 minutes, 16 for host, 16 for network, 16 for host, 2 to the power 16 for host. That means this many IP address for host. Okay. Then you can have different department, marketing department, sales department, IT, and then you can reserve IPs and some extra IPs for future expansion. This is the way you can plan it, department planning. Similarly, like CID also same thing. 10. This will provide 65,536 IP addresses. This CID 10.0.0.16. So public subnet, then private subnet in zone A, zone B. Then database also will have, right? This may be your web server. This is your application server. This will be your uh, maybe database server, right? And these are for future use. So this way you can design. What is the math behind CIDL planning? This last 16 minutes, 65,000 plus address. 16 bits for host. 18. This is 8 bits for host. Last 26 bits. 32 minus 26, 6 bits for host. 32 minus 25 minutes, 7. 32 minus 25, 7. 7 minutes, 2 to the power 7, 128 host. So we already discussed. So smaller the number, bigger the like larger the number of host. Okay. So smaller the number, bigger the number, larger number of host. Sorry, small number 16. So larger host. This is a big number, small number of host. Slash 26 big. Host is 64, and slash 16 small, large number of hosts 65,000. So we already discussed how we are doing this calculation inside their interview playlist. I think 40 or 41, I think it's there. AWS reserves 5 IP addresses in each subnet. So AWS reserves 5 IP addresses. So out of 128 or 64 or 65,000, 5 will be reserved. You cannot allocate to any host. First will be network address, we already know. Second IP is for VPC router. VPC router, second IP address. Third one is DNS server. Fourth one is for futures. Fifth one is a broadcast address. The last address is a broadcast address. First address is a network address. Second for VPC router. Third for DNS server. Fourth for futures. And last is a broadcast. First, second, third, fourth, and last are all reserved. So from fifth onward you can use, and before the last also you can use. So 256 IP slash 24 subnet means total 32 bits in IP. 30 minus 24 is 8. 8 means 2 to the power 8 is 256 IPs. Out of that, only 251 usable IP address. Rest 5 are reserved here. So 5 IP address reserved in each subnet for AWS, in AWS case. Why is a non-overlapping design critical? Yeah, if it is overlapping, there will be like a confusion, conflict, right? Same IP address in the same subnet. Each IP address exists in exactly one subnet, so routing decisions are ambiguous. Like if it's a unique IP address, routing decision is unambiguous. In a like neighborhood, if there are two houses with the same address, it will create confusion. So similarly, like we should avoid that. Network functionality overlapping subnets create routing conflicts. What are the rules for non-overlapping designs? What are the rules? Each subnet must have a unique CIDR block. CIDR block should be unique. Subnet CIDR must be subset of VPC CIDR. Subnet VPC CIDR is the like, a complete range. Subnet is a small part of it, so it should be subset of the VPC CIDR. So all this we discussed earlier in the CIDR interview playlist. No two subnets can have overlapping IP ranges. Plan for future growth. So these are the four rules. Each subnet must have a unique CIDR block. Subnet should be master. Subnet CIDR should be subset of VPC CIDR. No two subnets can have overlapping IP and plan for future growth. For example, by design with the VPC virtual private cloud CIDR 10.0.0.16. So subnet 1, this CIDR is different from this CIDR, right? There's 1.0.2.0.3.0. So this CIDR is different. So they are not overlapping. What route tables control? What exactly do route tables do? Route tables is like your navigation, right? If you go to your reception, they say that where is this cardiology or where is the pediatrician department, where is this department emergency. So they guide you, that they give you direction. Similarly, like in route table, the direction will be there. That this is the IP address. So where should I go? This IP address it should be local. So you have to go local. This IP address you have to go out when you go to internet. Right? So that is the way. What information is stored in route table? Destination, that is a CIDR block destination, where you want to go. Target, where to send traffic. If this destination, traffic should go where? Local, internet gateway, NR gateway, local, etc. Status, active or inactive, whether it's active or inactive. Propagated, whether the route was automatically added. Whether the route was automatically added. Whether it was as AWS or not. So, for example, here like PPC configuration, there is like a PPC CIDR, a range of IP address 10.0.16, public subnet and private subnet. It has two subnets, 10.0.10/24, 10.0.20/24. So how this is done, we have already discussed in CIDR interview playlist, how we distributed the allocated IP addresses in public and private for a particular layer. Right? And route table will have this. We can see one example route table also. Here is the one route table. This is the VPC, VPC dashboard. It has a subnet VPC and route table. Let's go to the route table. It has a route table. So route table will have a destination where I want to go. Target. If this pattern matches like 10.0.0.1 or 10.0.0.5, so that the IP address will go to the local because all those IP addresses are allocated locally. Right? Those are private IP addresses are allocated locally. So it should stay inside the VPC. Stay inside the VPC. Still only let's load. If 0/0, this filter matches everything. If it doesn't match, then we'll go by this. This is more specific, and this is like least specific. This means if this rule doesn't apply, then we'll go here and it will go to internet. Internet access by internet gateway. This is the public subnet. This is the public subnet. That's why it is going to internet gateway. Private table, again 10.0.0.16. This VPC range, VPC IP address range. VPC, I have said 10.0.0.16. So these are the IP address of VPC. So any IP address which are in VPC range should go to local. Otherwise, everything else should go to internet gateway. If it's not inside VPC, it should go to NAT gateway, internet access by NAT gateway. So this is the private, so that's why it's going to NAT gateway. Associated subnet is private subnet. So this first one, local is created automatically by VPC, means for every route table in VPC. Can be deleted or modified. Enable communication between all subnets within VPC. All traffic destined VPC CIDR range space or within VPC. Internet gateway is IEW something, some number will be there. Let's see here. Here you can see this IDW some number is there, internet gateway. All the 0.0.0/0 is going there. This is destination, target, status, and for the there now. We have the four things are there. Then we have subnet as usual, or the subnets as stated. Then age as usual, root propagation tag. Subnet as usual, okay, all these subnets are there associated with this root table. This root table is associated with all this subnet. Six subnets. Okay. NAND gateway, and it's like an add hyphens F6. So key concepts like a root priority have to match, the roots are evaluated by most specific match, longest preference match. So 10.0.15/32 is the most specific, and this is the least specific default root. So if it doesn't match, then check with this. If it doesn't match, check with this. Nothing matches, this is the default one. So root table will have main table, custom root table, and subnet association. Main root table default for all subnet, not explicitly associated. For any subnet, it's applicable. Custom root table created for specific routing requirements. And there are the other common targets. Local is for VPC internal routing, local. AWS internet gateway, NAT NAT gateway, BGW virtual private gateway, VPC peering, ANI network interface, I is it. What is default versus custom routes? The default is custom is automatically default is automatically created by AWS local route like 10.0.0.16 is the local. This is the default. Enable communication within VPC. So this is automatically created. So this is the default one within VPC communication. But outside custom route, you can decide that whether your traffic will go to internet gateway or private gateway. You may have another VPC, it should go there also VPC pairing connection. You may have VPN gateway, it should go to on-premise VPN gateway. So that you decide at this custom routes. Can I modify or delete default routes? Can I modify or delete default routes? No, it can't be modified. Default route can be modified. It's automatically managed by AWS. You can add custom routes, modify the main route table, but the local route always remains to enable inter-VPC communication. The default route is required to enable inter-VPC communication. How do subnets and route table work together? So subnet, it can be route table, it can be associated. We have seen this association here, right? So each subnet must be associated with exactly one route table. Each one table, one subnet. Multiple subnet can share same route table. Like earlier we have seen that here 6 subnets sharing one route table. 6 subnets sharing one route table we have seen this. So, but in inheritance, if you don't explicitly associate a subnet with the route table, then it uses VPC the main route table. If subnet doesn't have any particular route table, it will use the main route table by default. What is the common route table pattern? Public route table shared all public internets by all public subnets, contents route to internet gateway. Private route table shared by private subnets, contents route to NAT gateway. Database route table for database subnets may have no internet access, no route to internet at all. Custom route table for specific routing requirements like VPN, peering, etc. So these are the like 4 type of route table patterns are there: public, private, database. Like one is with the internet gateway, other one is a NAT gateway. Like if you need a outbound connection. The third one is no internet at all. Fourth one is a specific custom where you connect to VPN, VPC to VPC peering. So these are the 4 different things. How does writing research which part to take when multiple routes match? Multiple routes match means longest route. For example, if this package goes to 123 Oak Street, Spain, Illinois, US, everything is matching. So USA is a broad match. But this 123 Oak Street is the exact match, more specific. So broad match, then more specific, exact match. Right? Broad match, all user package. All Illinois package is a rule 2. That is more specific. Rule 3 is all Springfield packages, more specific. Rule 4 is a 123 Oak Street exact match. Similarly, for route table also. 000 means it's a broad match, matches everything. So first it will start with this match. If it is not matching, then it will go this, then this, like that. So here you can see that this address 110.100, 10.0.100, it's exactly matching IP address, VPC endpoint. So it matches exactly this one. So this is going to match. Otherwise, if it is a 10.0.1.99 or something, it will go to NAT gateway. Otherwise, it will go to local or then internet gateway. This is like both things won't be there in the same area, but this is the way it will be. There you are getting this point, how longest prefix matching and more specific matching. What happens if two routes have the same prefix length? So local route will have highest priority. Static routes manually added, then propagate route from between private connect. AWS uses priority order when prefix lengths are equal. If prefix lengths are equal, then it will be matching this local first, then static, then propagated. Then we have internet gateway. What is internet gateway? Internet gateway is basically like enable internet access, highly available, redundant and highly accessible by design, and stateless. It enable internet access. How many internet gateway can be attached to PVC? PVC only one. Only one internet gateway can be attached to VPC, virtual private cloud. Only one. However, you can detach IGW from one VPC and attach it to another. IGW itself can only be attached to one VPC at a time. It can be attached only to one VPC at a time. What is required for instance to access internet gateway through IGW? So what it needs? It needs a public IP address. Then subnet with a root table to internet gateway. One subnet is required, which is attached to a root table, which says that this traffic goes to internet gateway. Security group NACL must allow desired traffic. It should allow the traffic also to go. Right? An instance operating system must be configured to use the traffic. So if all these conditions met, then we'll be able to instance will be able to access internet through IDW. Public IP. This root is required, root table. And the NACL and other things security group should allow. And the instance operating system also configured to use that traffic. Why do private subnets need private subnet NAT gateway? So private subnet NAT gateway because it's outbound provides outbound internet access, inbound protection, no connection initially from the outside, no connection. Network address translation, it will do that translation. Private IP to NAT gateway, public IP for outbound traffic. So it will do the translation. So from private to public, NAT gateway public, and then it will be able to go out. High availability, AWS managed service, that high availability within AWS. What is the difference between NAT gateway and NAT instance? So NAT gateway is provided by AWS. NAT instance we can create. We can launch AWS instance install NAT, and we can have a NAT instance. This can be managed. This will be managed by our own, and this is like a highly available NAT gateway. This is a little expensive. This is AWS managed service, high performance, automatic failover within AZ, automatically planned, no security group, uses NACL only. More expensive but less managed overhead. So management overhead is less. NAT instance, self-managed EC2 instance. This is managed by us. Performance depends on the instance type. Manual failover configured with that. If failover happens, manually it has to be handled. Can use security group. Lower cost but requires more management. Where should I use, place NAT gateway for higher availability? For higher availability, deploy one NAT gateway in each AZ where you have private subnet. So each availability zone, put one NAT gateway. How routing determine the internet accessibility? Internet accessibility, that internet 00 goes to IGW, right? And for private, it's go to NAT outbound traffic. What determines the type of internet connectivity? IEW. IEW determines what is the 000 route. If the 0.0.0/0 pointing to IDW in route table, so means it's a bidirectional public. If it is a target is NAT gateway, outbound only internet access, private, only outbound access is available. And no route means no 0.0.0/0 entry in the route table means it's isolated. No internet access, nothing. It's isolated. Can I change subnet from public to private? Public to private, yes. You just remove, you just change 0.0.0 to NAT instead of IEW. Instead of internet gateway, point this one, whatever subnet, public subnet you have, point this 0.0 to NAT gateway instead of IEW. That will go to this is like a private subnet. Remember that instance also need appropriate IP address, public private to function calculate. That is also required. Okay. So let's go to the quiz section today. Which of the following subnets require a NAT gateway or NAT instance to access internet? Following subnet requires NAT gateway or NAT instance to access internet. We know that private subnet. Answer is B. What does CID block 000/0 represents in a root table? This represents all traffic to internet. Right? All traffic to internet. Represents all traffic to internet. What is the difference between NAT gateway and NAT instance? NAT gateway is a managed service, NAT instance is a self-managed. NAT instance self-managed. The answer is NAT gateway is a managed service. How do you make a subnet public in AWS? Just activate a route table 000 to internet gateway. If the 0 internet gateway activated, then it becomes public. What happens if the private subnet does not have access to NAT gateway or NAT instance? What will happen? Then instance can access only VPC local and internal services. It can't access internet. The instances can access only VPC local and internal services if private subnet does not have access to NAT gateway. The answer is only local internal services it can access. So that's it for today. Hope you like this video. Please like, share, and comment, and please subscribe to my YouTube channel, and also follow Devops channel. You have LinkedIn page. I post quiz and content daily, so you can participate in that. And also follow WhatsApp channel. I post regular update. Thank you for watching this video, and see you again in the next video.